In this video, I want to give you an introduction to solving multi-step equations, or in other words, solving equations that have variables on both sides. Alright, so we're going to walk through three different examples, and in each example, I'm going to point out a very specific principle that we need to make sure that we know and can use. So here's the first example, and it looks like we have a variable and a constant on both sides of the equation. So we need to decide on which side should we put the variables and on which side should we put those constants or the non-variable terms. Well, most students will look at it this way. We have a 6y on the left and a 4y on the right. 6 is larger than 4, so let's go ahead and put the variables on this left side, because on the left side is where the variables will have a coefficient that is positive. So let's go ahead and deal with that. So this 4y is positive, so let's subtract 4y from both sides. But while we're at it, since we know the variables are going to be on the left side, let's go ahead and take this positive 3 and get him off the left side and put him on the right side. Okay, so that's what that's going to look like. And so the first thing I want to point out in the video, this first principle, is that you can do multiple properties of equality at the same time. We don't just have to go one at a time. So these 3's will cancel, the 4y's will cancel, and it looks like in one foul swoop I've gone to 2y equals negative 14. So instead of having a variable and a constant on each side, now I have the variable on the left and the constant on the right. And that just took one step to do that. So to finish up, let's go ahead and divide both sides by 2. And I'll notice my value for y here is negative 7. And so here's another thing that I want to point out. Notice that this 3 was positive on the left side, and when I moved him to the right side, he became negative. Well, of course, that's because we were doing inverse operations. And the 4y that was positive became negative over here on the left. Once again, that's because we were doing those inverse operations, addition to subtraction and subtraction to addition. Well, we can kind of go away from these properties of equality, and we can think of it more of when you take a term from one side of the equation to the other side of the equation, you can do so simply by changing its sign. So the idea is, if you want to change sides with the term, you can do that, but you need to change its sign. So, change sides, change signs. So to take a term from the left to the right or the right to the left, you can change that side just by changing the sign of that term. In this second example, it seems like we have an equation that has a lot more terms and a lot more going on than that previous example. So I want to show you and point out another important principle here, is that most of these multi-step equations, after just a step or two, are all going to be whittled down to just a variable and a number equals a variable and a number, exactly like our first equation was presented to us. So let's go ahead and look at this, and here is our equals sign. So we'll deal with the expressions on the left and on the right independently, and we'll simplify these as much as we can first. So we'll go through and distribute here and also here, and then let's see what we have. Looks like negative 6n plus 15 minus 8 plus 4n, and that will equal n minus 2n minus 14. Okay, so at this point, again dealing with the expression on the left independently of the expression on the right, let's go ahead and combine like terms. So I have these numbers in the middle, and then our variable terms here on the outsides. And similarly, I can go ahead and combine those variable terms there. So let's do that. So we have negative 6n plus 4n, and that'll be negative 2n. And then 15 minus 8 will be a positive 7. And now looking at this right side, n minus 2n will be a negative n, and then a minus 14. So what do we have? Well, it looks like we have an equation with a variable and a number equals a variable and a number, exactly like the first equation was presented to us. So we discussed at the end of that first equation that we could take terms and take them from one side of the equation to the other side of the equation and simply just change their signs. So let's go ahead and put our variables on the right side, because when you look at the coefficients, I have -2 and -1. And of course, -1 is bigger than -2. It's further to the right on the number line. So we're going to take this -2 in, and we're going to move him and make him a +2 in. Similarly, we're going to go ahead and take this -14 and move him over and make him a +14. So when we do that, we'll have a 21 over here on the left, the 7 plus 14, and we'll have a positive n on the right. So it looks like 21 equals n, or in fact, if you like to put the variable on the left side, n equals 21. And we did that just using that symmetric property of equality, just switching the left side for the right and the right side for the left. So to look at that one more time, so we distributed and combined like terms, and we dealt with each expression totally independently of one another to begin with. And only after we whittled it down to a variable and a number equals a variable and a number, then we started changing sides with these terms. And what we had at the end here, n equals 21. In this third and final example, you'll notice on the left side of this equation we have a fraction. We have this 8x minus 3 being divided by 5. So probably the first thing I need to do is go ahead and deal with this fraction. So we see it's division by 5, and of course the inverse operation to division is multiplication. So let's go ahead and multiply both sides by 5. Well, on the left side, that's easy. The 5's just cancel. But on the right side, what exactly are we multiplying by 5? Well, we need to put parentheses around this expression, 2x minus 7, that was over here on the right side to begin with. And we need to distribute this 5. He'll be multiplied by every single term on that right side. So we have 8x minus 3 equals 10x minus 35 when I do that distribution. And see here once again, lo and behold, a variable and a number equals a variable and a number. So let's go ahead and take this positive 8x and move him over to the right side as a negative 8x. And we'll take this negative 35 and move him over as a positive 35. So it looks like we'll have 32 equals 2x. And a quick division will tell us that 16 equals x, or in fact x equals 16 if you like to see that variable on the left side. So anytime you're multiplying to get rid of fractions, or quite frankly, anytime you're using the multiplication property of equality, make sure that every single term gets multiplied by that value. So on the left side, the 5's cancel. That's why we didn't multiply through here, because they canceled out. But on the right side, we did need to do that distribution. So here's that third and final example.